In this video, we will use our knowledge of the trigonometric ratios, or SOHCAHTOA, to solve for missing sides and angles in a right triangle. So if you're given a triangle and you need to solve for a missing side, like in this first example, you cannot use Pythagorean theorem because you do not have two side lengths. Instead, you have a side length and a reference angle. So first thing you need to do, using the angle that's given to you, label your side lengths with opposite, adjacent, and hypotenuse. And of course, the minute you have one angle in a triangle, you technically have angle A as well, because you know that all three angles have to add up to 180, but that's not necessary. You don't have to solve for angle A at this time. So opposite to the 24 degrees is X. The hypotenuse is the longest side, which is 12, and it's across from the right angle. And then adjacent is side BC. Now, once you've labeled your triangle, you have to pick the correct ratio to use because you can choose sine, cos, or tan. So I'm just going to write SOHCAHTOA. And you want to pick the ratio that only has one unknown. And your ratio also has to have the side that you're looking for. So I'm looking for X, which is opposite. I'm not given adjacent, so that's useless to me, but I am given hypotenuse. So that would mean O and H. O and H is part of SO. That means I'm going to use sine. And now because I have my reference angle, I'm going to write sine 24 degrees is equal to the opposite is X and the hypotenuse is 12. And now, to isolate for X, you're just going to cross multiply. So the way we do that, we're going to put sine 24 over 1. And yes, you can put sine 24 in your calculator to get the decimal, but I don't want you to do that right away because you're going to cut down on the accuracy. So once I put it over 1, you can just draw a little cross here, and you're just going to multiply on the diagonal. So 1 times X is X, and 12 times sine 24. And now X is already isolated for, so you just go to your calculator and type in 12 times sine 24. So try that on your calculator right now. Maybe pause the video just to make sure you're using your calculator correctly. And now once you've done that, hopefully you get approximately, so I put my squiggles, and for side lengths, I typically want you to round to 1 decimal. So if you round properly, you should get 4.9 centimeters. So don't forget units, don't forget your rounding, and don't forget your approximate equal sign. All right, let's try the next one. So in triangle PQR, we're looking for X and we're given the reference angle of 54 degrees. So if I label my triangle, I know the hypotenuse is the blank side because it is the longest side and it's across from the right angle. Opposite the 54 is 8, and X is then left to be the adjacent side. So the hypotenuse is useless to me because I don't want to figure it out, and it also doesn't give me any information. I'm looking for my adjacent side, and I have my opposite. So if you're thinking of O and A, that would be part of TOA. So now to set it up, I will write tan 54 is equal to the opposite, which is 8, over the adjacent, which is X. And the order that you write your numbers in is very important. You have to have opposite on top. And then once again, we put tan 54 over 1, and then we do a quick cross multiplying. So now X times tan 54 degrees is equal to 1 times 8. So in this scenario, we haven't fully isolated for X. But remember, tan 54 is just a number. So you can just divide both sides by tan 54. And when you do it on the left side, they will cancel out. And on the right side, now you know what you have to plug into your calculator to isolate for X. So go ahead and take out your calculator and do 8 divided by tan 54. Maybe pause the video and then come back to check. So with proper rounding, hopefully you got 5.8 centimeters. If something went wrong, maybe your calculator is not in degree mode. Make sure it's in degree mode or else all of your answers will be off. All right, let's move on to triangle DEF. So here we are using 35 degrees as our reference angle. So I want you to pause the video, label your triangle, and identify the ratio you will use. Then come back to check your work with me. Okay, so opposite, adjacent, and hypotenuse. We're looking for the hypotenuse and we have the adjacent. So hopefully you thought about ka or cos. So now, if you haven't already done this, I want you to pause the video, set up your ratio, and try to solve for x and round to 1 decimal. Then come back to check your work. All right, so cos 35 should equal adjacent 18 over hypotenuse x. We put cos 35 over 1, and then we cross multiply. So x times cos 35 equals 1 times 18, and then we can divide both sides by cos 35. And when we do that, on the left side, we're just left with x. And when you plug in 18 divided by cos 35, you should get approximately 22.0 centimeters. All right, let's try the last one. So in triangle ABC, I want you to solve for x. 55 degrees is your reference angle. So I want you to pause the video and try this question fully. Label your triangle, pick your ratio, set it up, and isolate for x, and then come back to check your work. All right, so hopefully this is how you labeled your triangle and you picked sine for your ratio because we are looking for the opposite side and we're given the hypotenuse. So when you set up your ratio, you should have sine 55 degrees equals x over 5. And when you put sine 55 over 1 and cross multiply, you have x on its own right away because 1 times x is x. And then 5 times sine 55 is approximately 4.1 centimeters. So that's it for solving for sides. So you label your triangle based on the angle that's given to you, but never the 90 degree. And then pick your ratio using the side that you want to find and the side that you are given. And then you just cross multiply from your ratio setup.